everybody, and welcome back to Jumanji. Today we're asked to determine the hybridization of the carbon atoms in these two compounds. And hybrid orbitals are used to make sigma bonds and to hold lone pairs not used in resonance, right? So to determine the hybridization of an atom, you just count up the number of sigma bonds that atom has and the number of lone pairs it has that is not used in resonance, right? So all your terminal carbons here and here will have sp3 hybridizations, right? Because we just are expected to know that they're attached to three hydrogen atoms. So if we had three hydrogen atoms here, you would have 1, 2, 3, 4 sigma bonds, right? Making this sp3 because you have one s and 3 p's, right? So 4 bonds. Now for your carbon atom here, with your positive charge, your carbocation, you have a sp2 hybridization, right? Because you have 1, 2, 3 sigma bonds, right? There is no lone pairs here, and we have an empty p orbital, right? And I'll explain that in a minute. For your carbanion here, you have your 3 bonds, 1, 2, 3, right? But your negative charge here also comes with a lone pair, right? And this lone pair is not going to be used in resonance. So you have 1, 2, 3, and your lone pair, you have an sp3 hybridization here. All right, Jumanji. So how do we know that this carbocation has an empty p orbital and 3 bonds and is therefore sp2 hybridized, compared to your carbanion that has no empty p orbitals and is sp3 hybridized, right? For that, we need the electron configuration of carbon. We know that it is 1s2, right, 2s2, and 2p2. We also know that your first level, your lowest level, only has an s subshell, right? Your second level has an s and 3 p's. An electron goes in your lowest level first, and we fill that before we move on. So that's why your first level, the s, gets the 2 electrons, right? Now we have 4 more to go. Your s in your second shell is lower than the p, so it gets its 2 electrons first, right? Electrons come in pairs. So now we have 2 more electrons to go. Electrons will fill up one at a time, so one will go here, one will go here, and we run out of electrons, right? So if we had enough, we would have 1 in your p before we go ahead and fill in the pairs. But no, we are filled. We have 2, 4, and 6. So for here, we know we have an empty p orbital, right? sp2 hybridization. Now these electrons can also do something different, right? This s can say, you know what? I will promote one of my electrons and I will give it to this p, right? Now we all have an electrons. Now we have a hybrid orbitals with 1s and 3 p's, sp3 hybridized.